The internet runs almost everything around us. Messages, payments, navigation, streaming, entire businesses, millions of systems operating at the same time, all connected through one global network. It feels continuous, always available as if it's simply there whenever you reach for it. So the question becomes unavoidable. If something is this central, this widespread, could it be turned off? At first, the idea doesn't seem that strange. We turn off machines every day. Power grids can be shut down, systems can be disabled, entire platforms can go offline. So it's natural to assume that somewhere, at some level, the internet must have a similar kind of control, a place where everything connects, a point where, if switched off, everything else follows. Well, to answer that, you need to understand how the internet was built. In 1969, a project called ARPANET connected a handful of computers between universities in the United States. The goal was simple: allow these machines to communicate and share information over long distances. At the time, this was a major step forward. Computers weren't designed to talk to each other in this way. What made this system different was how the connections were structured. Instead of relying on a single direct line between 2 points, ARPANET allowed data to move across multiple paths. Information could travel from one computer to another through different routes, passing through intermediate machines along the way. It wasn't fixed, it was flexible. As more institutions joined, the network expanded, new connections were added, more computers became part of the system, and over time, separate networks began linking together, forming a larger structure. By the 1980s, protocols like TCP/IP were introduced, allowing different networks to communicate using a shared set of rules. This made it possible for independent systems to connect while still operating on their own. From there, growth accelerated. Universities connected to research centers. Private companies built their own networks. Eventually, this evolving system became what we now recognize as the internet. Basically, the internet means a network of computers. Now, for all of these independent networks to function as one system, several key components have to operate together continuously, which makes it hard to shut it down. At the most basic level, everything starts with your connection. Before anything else can happen, your phone or computer needs a way into the internet. That connection comes from your internet provider, often called an ISP. It's the service that links your home, your phone, or your school to the rest of the online world. Without it, your device is completely isolated. Once you're connected, you can ask for something. When you open a website or an app, your device sends a request. That request needs to go somewhere. And that's where servers come in. A server is simply a powerful computer that stores websites, videos, apps, and other online content. So when you open a site, your device is reaching out to one of these computers to get the information. Now the question becomes how that request finds the right place. First, the domain name system, or DNS, helps your device figure out where the website is. Humans use names like youtube.com or google.com, but computers use number addresses called IP addresses. DNS acts like a translator. It takes the name you type and matches it to the number address the system actually needs. Then come the routing systems. Their job is to decide which path the data should take. They guide the request across different networks, helping it move from one point to another until it reaches the correct server. And all of this travels through physical cables that run under streets, across countries, and even under oceans. These cables carry the data at extremely high speeds between different parts of the world. All of that happens in seconds, every time you go online. And for you to shut down the internet, you will have to affect all of those areas and parts, which becomes the tricky part. But even with all that, parts of the internet do fail. We have seen it. Governments can restrict connectivity within their borders, limiting or completely blocking internet traffic. How do they do it? Quite simple. You see, inside a country, most people connect to the internet through a small number of providers. You remember the providers we talked about? The service that links your phone to the rest of the online world? Yes, those ones. These providers act as the main entry points between users and the global network. Because of that, governments can control access by giving instructions to those providers. The most direct method is a full shutdown. Providers can be ordered to stop all internet traffic, disconnecting users from the wider network. Devices are still there, networks still exist, but the connection to the outside world is cut. It's like you're ready to go outside, but someone locks all the doors. You're still there, you just can't get out. There are also more targeted approaches. Instead of shutting everything down, specific websites or services can be blocked. This often happens through systems like the domain name system, or DNS. When a user tries to access a website, the system simply fails to return the correct address, making the site unreachable. Another method involves blocking IP addresses. Every website has a numerical address, and if those addresses are restricted, devices are unable to connect, even though the site itself is still running elsewhere. In more advanced cases, traffic can be monitored and filtered in real time. This allows certain apps or platforms to be slowed down or blocked, while others continue to work normally. From the user's perspective, some parts of the internet remain available while others seem to stop functioning. But across all of these scenarios, one pattern remains consistent. Failures are localized. They affect specific regions, specific systems, or specific networks. The rest of the internet continues to function, adapting to the disruption. Which brings us to the key point. If individual failures don't bring the system down, what would it actually take to affect everything at once? For the internet to stop worldwide, multiple systems would have to fail at the same time, across different regions and across different layers of the infrastructure. One possibility is a large-scale power failure. Without electricity, data centers shut down, routing systems stop operating, and communication links go offline. But power systems are also distributed. Different regions operate independently, which means outages tend to remain limited in scope rather than global. Another scenario involves coordinated disruption. If major backbone networks, data centers, and routing systems were all taken offline at once, large portions of the internet could become unreachable. But achieving that level of coordination across different countries, companies, and infrastructures is extremely complex. But even in these scenarios, the same challenge remains. The internet is not concentrated in one place. It exists across many independent systems, each with its own infrastructure and controls. So affecting everything at once would require a level of simultaneous disruption that goes far beyond a single failure or a single point of control. So after everything we've broken down, the scale, the structure, the way data moves, and how failures behave, the answer becomes much clearer. There is no global switch. The internet cannot be turned off as a single system, because it isn't a single system. It's a collection of independent networks, each operating on its own infrastructure, connected through shared protocols. No single entity controls all of them. No single point connects all of them. And because of that, there is no single point that can shut them all down. Even if large parts of the network were disrupted, other parts would continue to operate. Traffic would reroute, systems would adapt. Some regions might lose access temporarily, but the entire global network wouldn't disappear at once. The structure itself prevents that kind of total shutdown. Quite interesting, right? Exactly. See you in the next video.